Today we are going to graph and write equations of lines. So first thing off, it says to graph lines, we need to plot the given points first. So if they give us a point to plot, we're going to start with that. And then we're going to count our slope, our rise over our run, or our fall over our run, between the 2 points to identify what the slope is. Okay, if we're given a point and slope, we're going to plot the point first, and then we're going to rise over run, whatever the slope number is, to find more points on the line, and we really want to find the y-intercept. This all makes sense once we get going. So the main reason why we want to find the y-intercept is because if we want to write an equation in slope-intercept form, we have to know the slope and we have to know the y-intercept. Just like the name says, slope-intercept. So as long as I know the slope and the y-intercept, I'll be able to write the equation, which is part of what we're doing today. So we do want to graph the lines, but we also want to write their equations. Okay, let's look at this first example. It gives me 2 points to plot. So like it said up above, if I'm ever given point to plot, I want to plot them. So let's plot negative 6, 4. Remember, negative 6 is the x-coordinate and 4 is the y-coordinate. Since the x-axis runs left and right, that negative 6 is telling me to go left 6. So 1, 2, 3, 4, 5, 6. And the y-coordinate is telling me to go up 4. 1, 2, 3, 4. So that's my point, negative 6, 4. Now I want to plot the point 3, 10. 3 is the x-coordinate. 10 is the y-coordinate. So 3 is what I do to the right, and 10 is what I'm going to go up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I want to write the equation of this line, then I need to figure out the slope, and I'll also need to figure out the y-intercept. Well, if I want to find my slope, all I have to do is count how I get from this left point to this right point. What do I rise, and what do I run? Before I do that, let me just go, I'll count it first. So to get from here to here, I go up 1, 2, 3, 4, 5, 6, and to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went up 6, so that's a positive 6. I went right 9, so that's a positive 9. Will that reduce? Divide both of those numbers by 3, and you get 2/3. Okay, if I want to find the y-intercept, instead of just trying to draw the line, which is what I was about to do a minute ago, and kind of eyeball where it crosses the y-axis, I'm going to be a little more specific, and I'm going to plot this slope of 2/3 from this point until I get to this one. So since the 2 is positive, I'm going to go up 2, and since the 3 is positive, I'm going to go right 3. So up 2, right 3, put a new point. Do it again. Up 2, right 3, put a new point. Up 2, right 3. Okay, now I can draw a little bit more precise line, but the great thing about my line is now I don't have to eyeball where the y-intercept is. I see it exactly where it is. So where does it cross our y-axis? Can you count that? It crosses the y-axis at 8, at the point 0, 8. Remember, y-intercepts always have an x-coordinate of 0. Okay, so if I want to write my equation, I can now put it in slope-intercept form, y equals mx plus b. Remember, I only have to know 2 pieces of information, the m and the b. And we found the slope to be 2/3. So 2/3 is going to go where the m is. I recopy the x, the equals, and y. And then we found the y-intercept to be a positive 8, so I put plus 8. And there's our equation. Okay, off to the side, you're going to see something about domain and range. We've talked about these before, but it's a little different today. So first of all, do you remember domain is that x or y? Domain are your x's, and range, those are your y's. Remember, Dr. XY. Domain are x's, range are y's. Okay, domain wants to know what's happening with your x's. Since the x-axis runs left and right, I want to know what's happening with my line left and right. So as I start cruising this way, I'm going left, left, left. This arrow means I'm going to go forever left. As I start cruising this way, I'm going right, right, right. This arrow means I'm going to go forever right. If you ever go forever to the left and forever to the right, you're going to hit all your negatives and all your positives, which we call all real numbers. And there is a symbol for that. I draw two straight up and down lines, and then I make an R. You can kind of see the A and the R for all real numbers. Okay, range are your Y's. The y-axis runs up and down, so I want to know what's happening with this line up and down. So as I start cruising this way, I'm going down, down, down. This arrow means I'm going to go forever down. As I go this way, I go up, up, up. That arrow means I go forever up. If you ever go forever down, forever up, you'll hit all the negatives, all the positives. So that is called all real numbers. And to show you the symbol again, two straight up and down lines. Now make an R. There it is. Okay, number 2. This one's a little different than the last one. They give us only 1 point and a slope. So remember, if they ever give us a point to plot, I'm going to plot that first. So -5, -5. Our x-coordinate's -5, our y-coordinate's -5. The x-coordinate's what you do left or right, so I'm going to go left 5. The y-coordinate's what you do up or down, so I'm going to go down 5. Now I'm going to plot my slope. What is 2 understood to be over? 1. Every number is understood to be over an imaginary 1. So since the top number is positive, I'm going to go up. And since the bottom number is positive, I'm going to go right. Remember, slope is rise over run or fall over run. So from my point I plotted, I'm going to go up 2, right 1. Do it again. 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 Up 2, right 1. One more time. Up 2, right 1. Okay, I'm going to go ahead and draw my line as neatly as I can. All right, we know the slope is 2, or 2 over 1. The y-intercept is wherever the graph touches the y-axis. And where does it touch the y-axis? Can you count it? At 5, so that's 0, 5. Now I can write my equation in slope-intercept form. So every time I want to write an equation in slope-intercept form, I only need to know 2 things, slope and the y-intercept. What was the slope? 2. So 2 goes where the m is. Recopy the x, the equals, and y. And what did we say the y-intercept was? That's right, a positive 5. And there's the equation of our line in slope-intercept form. Okay, domain and range. Remember, domain is about the x's, what's happening left and right. Range is about the y's, what's happening up and down. So if I look at my line left and right, it's going forever left, forever right. So if it ever goes forever left, forever right, it hits all the negatives, all the positives, all real numbers. I'm just going to draw the symbol this time. Range are your y's, that's up and down. So forever down, forever up, hits all the negatives, all the positives. So the range is all real numbers. Okay, let's look at number 3. Number 3 gives me a point, and it tells me the slope is undefined. So remember, if we're ever given a point, we're going to start with that first. So I'm going to plot my point of 3, 0. So I'm going to go right 3, and then I don't go up or down. Now, if the slope is undefined, do you remember what that looks like? Think about your slope, dude. When the slope's undefined, it is vertical. Can't climb up those really steep vertical walls, impossible to do, so the slope's undefined. Okay, so the slope we already know is undefined. B, the y-intercept. Where does my blue line cross this y-axis? Does it ever cross or touch the y-axis? It doesn't. So this does not have a y-intercept, so we write none. Okay, now the equation's different. So one thing I want you to know is if you ever see a diagonal line, you're going to have an x and a y in the equation. Diagonal line, x and a y in the equation. If you don't see a diagonal line, there's only going to be one letter in the equation. It will either be x equals or y equals? Well, my x-coordinate right here is 3. My x-coordinate right here is 3. My x-coordinate here is 3. My x-coordinate here is 3. Now my y's keep changing. Here I'm at 3, 0. Here I'm at 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. So the y's keep getting bigger and bigger as I go up, but the x's always stay 3. So we call this equation x equals 3. And one way you can remember this is if you ever have an x equals line, it means the line only crosses the x-axis. So if you have a line that ever just crosses the x-axis, it's going to say x equals. So let's just make a note of that. It only crosses the x-axis. Okay, let's talk about domain and range. Domain are your x's, what's happening left and right. So here my x value is a what? A 3. Do you ever see any x's smaller than that or bigger than that on this line? Nope. Everywhere on this line your x's has a value of 3. You're nowhere to the right, nowhere to the left. So the only thing we have for the domain is x equals 3. Now range are your y's. That's what's happening up and down. So does this graph go forever down? Yep. Does it go forever up? Yep. If a line ever goes forever down, forever up, then the range will be all real numbers. Okay, let's flip to the back side. Okay, on this problem, we are given the slope and the y-intercept. So the y-intercept is a point, so I'm going to start with that. So I'm going to plot my y-intercept at 3. Remember, y-intercepts are where the graph touches the y-axis. So that's why I went to 3 on the y-axis. Now my slope is a negative 2/3. I always like to think of that negative with the numerator. So since it's a negative 2, I'm going to go down 2. And since it's a positive 3, I'm going to go right 3. So from my y-intercept, I go down 2, right 3. Put a new point. Let's do it again. Down 2, right 3. Now, I could go reverse. Instead of down 2 and right 3, I could go opposite. Up 2 and left 3. Up 2 and left 3. Notice it makes the same line. Okay, so now I can write my equation. Remember, to write an equation in slope-intercept form, we only have to know the slope and y-intercept. Do we know both of those things right now? Sure we do. So what would the equation look like? Y equals negative 2/3 x plus 3. All right, let's talk domain and range. Domain are your x's, what's happening left and right. And this graph goes forever to the left, forever to the right. Forever left, forever right. All real numbers. Range are your y's, and that's up and down. And this graph goes forever down, forever up, forever down, forever up. So the range, all real numbers. All right, number 5. This is actually given to me in slope-intercept form. You can see it follows that format, y equals mx plus b. Now, one thing I haven't said before, when an equation's in slope-intercept form, you can think of b as begin. We're going to begin by plotting the y-intercept because it's the point they give us. And you can think of move for your slope. The slope is how we move, rise over run, or fall over run from place to place. Okay, so first thing I'm going to do is I'm going to plot my y-intercept, and my y-intercept is a negative 5. So remember, y-intercepts are always on the y-axis. So I'm going to go down to negative 5 on the y-axis and plot that point. My slope is a number in front of the x, so my slope is 4. And remember, 4 is understood to be over a 1, you just don't see it. Since it's a positive 4, we go up, and since it's a positive 1, we go right. So from my y-intercept, I go up 4, 1, 2, 3, 4, right 1, put the dot. Do it again. Up 4, 1, 2, 3, 4, right 1, put the new dot. Okay, let's go ahead and draw our line. Now I don't have to write the equation of it this time because that's how the problem started. Okay, what do you think about domain? Domain are your x's. X-axis is left and right. Does this line go forever left, forever right? Sure it does. Domain, all real numbers. Range are your y's. The y-axis is up and down. So look at this line going up and down. Does this line go forever down, forever up? Sure it does. Range is all real numbers. Okay, number 6. This time they actually drew the line for us. We just need to fill out the rest of the stuff. So if I want to find the slope, I need to count my rise over run or my fall over run. So I can pick any 2 points on this line, it doesn't matter which 2, and I'm just going to pick this one and this one. So to get from here to here, I fall 1, so that's a negative 1, and I run 1, so that's a positive 1, which I can just think of as negative 1. The B is the y-intercept, and where does this line touch or cross the y-axis? And it crosses right there. And what is that point? 0, 2. So now I can write my equation in slope-intercept form because I just figured out my slope and I just figured out my y-intercept. What would it look like? Y equals negative 1x plus 2. Or I could just write that y equals negative x plus 2. We don't need to write that 1 in front of the x. It's understood to be there. Okay, domain and range. What do you think? Domain are x's. X-axis is left and right. Does this line go forever left, forever right? Sure does. All reals. Range are your y's. That's up and down. Does this line go forever down, forever up? Sure does. Range is all reals. Have you noticed anything about our diagonal line yet? Every time we've had a diagonal line, our domain and our range has been all real numbers. Because diagonal lines always go forever left, forever right, forever up, forever down. Every time you have a diagonal line, that's going to be the case. Okay, and last one, number 7. This time they didn't draw the line, they just gave us 2 points. So pretty much like number 6. First I'm going to find my slope. So to get from the left point to the right point, what do I rise, what do I run? I rise 2, I run 1. So my slope is 2 over 1, which we could just write as a 2. Now, I don't see where the line crosses the y-axis, so I need to continue my slope. So up 2, right 1. From here, I'm going to do it again. Up 2, right 1. Put your new dot. Do it again. Up 2, right 1. Let's do it one more time. Up 2, right 1. Now, I can see where my line touches the y-axis. Take a second, count that. Where does it cross? At 0, 7. So now I can write my equation in slope-intercept form because I know my slope and I know my y-intercept. And what would it look like? Y equals 2x plus 7. Okay, domain and range. Does the line go forever left, forever right? Yep, all reals. Does the line go forever down, forever up? Yep, all reals. And there is some graphing and some writing equations of lines. Did you have fun? Smiley face. Thank you.